Hope my voice is audible. So this time I'm going to handle a subject called VLSI design, and the subject code is 8EC72. So before moving to the subject, let us see what is VLSI. What is the full form of VLSI? Here the VLSI stands for Very Large Scale Integration. VLSI is nothing but it is the process of creating integrated circuit by combining billions or millions of transistors onto a single chip. Very large scale integration. It is the process of creating an integrated circuit by combining billions or millions of transistors onto a single chip. So this VLSI has begun in the year of 1970. And coming to the applications, this VLSI, it is mainly used in the manufacture of electronic components like microprocessors as well as memory chips. And if you consider this VLSI is a hardware. Now we'll see what are the various modules which cover in this subject. So first we're going to discuss with module 1. So the module 1 is a brief introduction as well as MOS transistor theory. And the second is fabrication and small scale geometry effects. And module 3 is delay and combinational circuits. And module 4 is dynamic logic circuits. And module 5 is semiconductor memories and testing. Now, in today's class, we're going to discuss the module 1 and what are the topics which we covered in module 1. So, in first part, we have introduction. So, here, mainly we will going to discuss with a brief history, MOS transistors, as well as CMOS logic. And the second part is MOS transistor theory. So in MOS transistor theory, we will going to study introduction to MOS transistor theory, the long channel current to voltage characteristics, non-ideal current to voltage effects, as well as DC transfer characteristics. Let's move on to the brief history of VLSI. So improvement in integrated circuits have enabled space exploration and made automobiles safer and more fuel efficient, revolutionized the nature of wafer, and it brought much mankind knowledge to our web browsers and made the world a flatter place. So if there is an improvement in integrated circuits, it makes explore to the space, and it also makes the automobiles to be run in safer way, and it becomes more fuel efficient, and it revolutionized the nature of wafer, and it brought much more mankind knowledge to our web browsers, and it makes a world a flatter place. So you can see in the next figure, the figure 1.1, it shows the annual sales in the worldwide semiconductor market. So as you know that the integrated circuit become a $100 billion a year business in 1994. So in 2007, the industry manufactured approximately 6 quintillion transistors, are nearly a billion for every human being on the planet. Here, thousands of engineers have made their fortunes in the field. New fortunes lie ahead for those with innovative ideas and talent to bring those ideas to reality. So here you can see the size of the transistors to be increased or doubled for every 2 years. So in the vertical column, you can see the global semiconductor buildings. In the horizontal column, you can see the year. Here the figure shows the size of worldwide semiconductor market. So here the size of a transistor should be doubles for every 2 years. So during the first half of the 20th century, electronic circuits used large expensive, power hungry, and unreliable vacuum tubes. So during the first half of the 20th century, these electronic circuits are very, very large, and these circuits are highly expensive and they consume more power, and they are unreliable vacuum tubes. So in 1947, John Bardeen and Walter Bratton built the first functioning point contact transistor at Bell Laboratories, which is shown in figure 1.2. So it was mainly classified as a military secret, but Bell Labs publicly introduced the device in the following year. Next, 10 years later, the Jack Kilby at Texas Instruments realized the potential for miniaturization if multiple transistors could be built on one piece of silicon. The figure 1.2b shows its first prototype of an integrated circuit, and this prototype is constructed from a germanium slice and gold wires. That one we have called it the transistor because it is a resistor or semiconductor device, and it has the ability to amplify electrical signals as they are transferred through it from input to output terminals. So here you can see the first figure. This is a first transistor. It is a property of AT and T archives, and it has to be reprinted with permission of AT and T. Again, the figure B, which shows the first integrated circuit courtesy of Texas Instruments. As you know that the transistor can be viewed as electrically controlled switches with a control terminal and two other terminals that are connected or disconnected depending on the voltage or current applied to the control. So as you know that the transistor can be viewed as electrically controlled switches, and it has three important terminals. The middle one we can call it as a control terminal, and we'll be having two other terminals. These two terminals should be connected or disconnected, depends on the voltage or current applied to the control. So transistor have three terminals. Next, soon after inventing the point contact transistor, Bell Labs developed the bipolar junction transistor. As you know that the bipolar transistors were more reliable, they are less noisy and more power efficient. So even in the early days of integrated circuit, primarily used bipolar transistor. But one of the fact to this bipolar transistor is it requires a small current into the control, which means base terminal, to switch much larger currents between other two terminals. So as you know that we will be having, if you consider bipolar transistor, we have three terminals. One is base. Here we are having emitter. Another one we will be having collector. So the bipolar transistor require a small current into the control, that is base terminal, and large amount of currents between emitter as well as collector terminal. So next we're going to see the invention of the transistor. So as you know that the vacuum tubes ruled in the first half of the 20th century, and they are very large, expensive, and they consume more power, and they can be considered as unreliable. So in 1947, the first point contact transistor, it has been discovered by John Bardeen and Walter Bratton at Bell Labs. It looks like a crystal pipe. So next we have two different types of transistor. One is bipolar transistor, another one is metal oxide semiconductor field effect transistor. So in shortly, we can call it as MOSFET. We have two different types of transistor. One is bipolar transistor, another one is MOSFET. So let us see what are these bipolar transistors. So the bipolar transistor has NPN or PNP silicon structure. Usually the bipolar transistors has NPN or PNP silicon structure. and there will be a small current into very thin base layer. So as we know that we have three terminals, base, emitter as well as collector. So there will be a small current into base layer, but the large currents between emitter and collector. Here the base current limits the integration density. Next, we'll move on to MOSFET. So as we know that we have two different types of MOSFET. One is N MOSFET, another one is P MOSFET. So N MOSFET stands for N channel MOSFET and P MOSFET stands for P channel MOSFET. Here, voltage applied to the insulated gate controls current between source and drain. If you consider any of the MOSFET, here we are having three terminals. One is gate terminal, source as well as drain terminal. So we have three important terminals: source, gate as well as drain terminal. So here the voltage should be applied at the gate terminal that controls current between source as well as drain terminal. And it has low power, allows for very high integration.